everyone, welcome back to my YouTube channel. My name is Rakshita S. I am studying CSE Engineering in Sri Venkateshwara College of Engineering, Bangalore. I am belong to the Department of Basic Science of Section Chevrolet. Today I am going to explain the topic of optical fibers. And content is the principle and structure, acceptance angle, numerical aperture and numerical aperture of optical fibers. Let us discuss about a principle and structure of optical fibers. Optical fibers are thin strands of flexible and transparent material that can transmit light signals over a long distance. They consist of a core which carries the light signals. You can see the core. Here the structure is there of optical fibers and a cladding which surrounds the core and helps to guide the light within the fiber. The core and cladding are made up of materials with a different refractive indices to enable total internal reflection of light. We can see the structure of optical fibers which consist of a plastic jacket, cladding and core. And acceptance angle of optical fiber. The acceptance angle is the maximum angle at which light can enter an optical fiber and still be transmitted effectively. It is determined by a refractive indices of the core and cladding materials. Light entering the fiber at an angle greater than the acceptance angle will undergo excessive attenuation or a leakage. And the numerical aperture of optical fibers. The numerical aperture is a measure of the light gathering ability of an optical fiber. It is a dimensionless quality defined as the sine of the acceptance angle multiplied by the refractive indices of the medium surrounding the fiber. A higher numerical aperture indicates a greater ability to collect light and can result in a better light transmission and higher data rate. Here we can observe a numerical aperture is equal to sine alpha is equal to the root of n1 square minus n2 square, and the full acceptance angle formula is equal to 2 alpha. And the relationship between acceptance angle and numerical aperture. The acceptance angle and numerical aperture are directly related. The numerical aperture is equal to the sine of the acceptance angle. A larger acceptance angle corresponds to a larger numerical aperture, indicating a higher light gathering ability. And we can discuss the importance of a numerical aperture in fiber optic communication. The numerical aperture determines the amount of light that can be coupled into an optical fiber. Higher numerical aperture fibers allow for a better coupling of light, resulting in increased data transmission rate. Fiber with a higher numerical aperture is more suitable for applications that require high efficiency light collections such as medical, imaging and sensing. And the types of fiber in numerical aperture. You can observe the picture here. The types of fiber, the multi-mode and the single mode UPS and single mode APS. And the different types of optical fibers have a varying numerical aperture. Multi-mode fibers typically have a larger numerical apertures, allowing for easier coupling of light from a broader range of angles. Single mode fibers used for a long distance communication generally have a smaller numerical apertures for more precise light propagation. And what are all for the factors affecting the numerical aperture, which the numerical aperture of an optical fiber can be influenced by several factors, including the refractive index of the core and cladding material. The core diameter and cladding thickness also impact the numerical aperture. Higher refractive indices and larger core diameter leads to a higher numerical aperture. You can observe the picture which the concept of a numerical aperture for objectives and condensers. And the last is a summary. Optical fibers are structured with a core and cladding for light transmission. The acceptance angle determines the maximum angle at which light can enter the fiber. Numerical aperture represents the light gathering ability of the fiber. Thank you for watching my videos. Please keep supporting for more videos. Thank you.